Hey guys, last week we talked about prisms and cylinders. This week we're going to be working with more polyhedrons, specifically pyramids. So the polyhedron pyramid, what a pyramid is, it consists of it consists of a polygon base and lateral faces that intersect to form a point that's called the apex or vertex of the pyramid. The polygon base can be any type of polygon. It can be concave or convex. But our traditional, most common pyramid is just a square pyramid. These are like the pyramids in Giza, essentially the ones in Mexico, and the one in Antarctica where the predators were in Alien vs. Predator. All right. So we've got this pyramid. That polygon at the bottom is the base. And the edges along the base are called the base edges. The triangles are your lateral faces. And where the triangles meet are called the lateral edges. And the lateral edges all intersect at a point called either the vertex or the apex. Either is acceptable. More often than not, it's referred to as the vertex, but they're interchangeable. All right, so that's what a pyramid is. If the base has 5 sides, it's going to have 5 lateral faces. If the base has 22 sides, it's going to have 22 lateral faces. There are several ways to go about making the net of a pyramid, but the easiest and the most straightforward, say we had a pentagonal pyramid, is to have your base, and then your triangles all around it. And these triangles would fold up to form the vertex, and that would be the net of our pentagonal pyramid. And we have the base area, and the areas of the triangles. Those triangles is the lateral area. Just like we have the lateral area with the prisms. But there's a difference with the lateral area here. With these 5 triangles, if we take these 5 triangles, we could lay them out, 3, 4, 5. Like that. Such that these are the sides that make the perimeter of the base. Now, unfortunately, not every type of pyramid is going to have these triangles have the same height. Not every one is going to have the same height. But if they do, the lateral area is 1/2 times the perimeter of the base times the height of these triangles. But I'm actually going to erase that h. I'm not going to leave that as an h. And the reason being is, if we take that and we make our pyramid, just a rough 3D sketch of our pyramid, the height of those triangles, of those lateral faces, is right here. That's not the same as the height of the actual pyramid. The height of the pyramid is the distance from the base to the vertex. That's the height of the pyramid. So that's the height of our pyramid. So this distance is the height of the lateral faces. We call the height of our lateral faces the slant height. And the variable we use for that is a cursive L. So the actual height of the pyramid is not going to be the height of the lateral faces. The height of our lateral faces is the slant height. So our lateral area is 1/2 times the perimeter of the base times the slant height, if all the lateral faces have the same slant height. And that means the total surface area, it's the area of the base plus that lateral area. We are only going to deal with pyramids where the slant height is all the same. Those are the only types of pyramids I'll ask you about the surface area, unless it's a really straightforward one, like a triangular pyramid. That's just finding the area of 4 triangles and adding them up. So it doesn't need to have the same slant height if it's a triangular pyramid, but otherwise it will. So what that means is we're only going to be dealing with right pyramids. And right pyramids occur when the vertex is directly above the center of the base. So that means the height from the vertex to the base contains the vertex and the center of the base. Let's say we had a square pyramid. But the height was directly above the midpoint of one of the sides. If we had this slant height is shorter than the height of this lateral face in the front. This one on the side has a smaller height than this one on the front. So if that vertex is not above the center, these lateral heights are going to be different. So you can't just do that the area of those 4 triangles is 1/2 times the perimeter of the base times the slant height. So that's why we're not going to do much with oblique pyramids, where the height is not with the vertex and the center of the base. So that's surface area. It's the area of all the surfaces together. There's also the volume of a pyramid. Now, there are ways to prove this with calculus, but we are in honors geometry, so we don't know calculus. So we're going to find a general case and extrapolate from that to work with volume. Now we know prisms, volume of a prism, it's the area of the base times the height. And the easiest type of prisms to work with are rectangular prisms. And the easiest rectangular prisms are cubes. So here's what I'm going to do. I'm going to take a square pyramid, because a square is what builds cubes. I'm going to take a square pyramid such that the base is a square and the height of the square pyramid is half the side length. All right? So I'm going to take that square pyramid such that the height of the square pyramid is half the side length. Now, if I made another pyramid with those same dimensions, it will be congruent. It will be the same exact size, so have the same exact area. So I'm going to make another one. But the way I'm going to position it is I'm going to have it vertex to vertex. It will be kind of like an hourglass figure. So we've got a pyramid above, so SS, and the height of this one is 1/2 S. So that means this total height is S. If it's 1/2 S and 1/2 S, the total height is S. So if I connected these two, we have that square, and then by tracing over these, I've just made another of those pyramids nestled into this right side. And that's 1/2 S. And I could do the same thing on the other side. That's S. From there to there is S. And then we have these making that pyramid on the other side. And then we can do the same thing with the front and back. We can take another one of these pyramids and nestle it into this front with an S by S square and the vertex going to the center there. And then another one in the back. So we've got the front and back, the top and bottom, the left and right. We've got 6 pyramids producing 1 cube. We've got 6 pyramids producing 1 cube. Just need a little more room over there. So that means 6 of the volume of the pyramid would equal the volume of the cube, which is S cubed. All right. Now, the volume of the pyramid, S cubed isn't all of the measurements of the pyramid, but it's 2 of them. So 6 times the volume of the pyramid equals S squared times S. Well, S squared is the area of the base of the pyramid. And S is part of our last measurement. The area of the base is S squared, and the height is S over 2. So S is really 2 times your height. So if you divide by 6, the volume of your pyramid is 2 over 6, which is 1/3 area of the base times the height. This formula actually extrapolates for every pyramid. every type of pyramid, whether the base is a square, a triangle, an octagon, an icosahexagon, tetragon. It doesn't matter. The volume of the pyramid is 1/3 times the area of the base times the height. Every single time. All right. So that's what you need to know about pyramids. Have fun.